Okay, now, okay. You can start asking questions related to module number 4. This is confidence interval. Any question? Actually, I can't hear anything if you are saying or something. I can't see any question from anyone.
Can we just go over some of the stuff?
Okay. So first thing first, what is confidence interval? What do you understand? Let's say I am asking you a simple question. Today you will be driving from Seattle to Spokane. What would be your speed of driving? What would be your driving speed?
60.
Okay, 60. You are saying exactly 60?
No. But there has to be a margin of error, right?
Yeah. So basically, it will be like you say, you will be driving between 60 or 65 miles per hour, or 60 to 70, or 60 to 80, depend on the traffic. So basically, this is a confidence interval that you are confident that you will be driving within this range. And that is what is called confidence interval. If I ask another question, what would be your GPA at the end of MBA? You can't say your GPA will be 3.498 or 3.956, or you can't say precisely that will be your GPA, isn't it? You will say that your GPA will be in between 3.8 to 3.9, or whatever. So the narrow the range you give, more chance of risk is there that that can escape from that. So you understand why we are doing this confidence interval with what because we are not able to say exactly, okay, I will be driving with 60.2 miles per hour from Seattle to Spokane. No, you can't make it this kind of, but with probability, with confidence, okay, you can decide the range. So always we can make a range, like anything that you see in practical world, people predict based on range. Okay, this will be in this range, you will have the same. Similarly, in confidence interval, we are going to learn what is confidence interval. Let's say I'm just going to give you very simple example right here that I normally give to my other class. And let me share that. Okay, can you see my screen? What this Minitab?
Yes.
Okay. So actually the situation is this: how many students are coming to USA every year? There are almost 300,000 new students come every year. How many? About 300,000 students every year come to USA for pursuing different studies, masters, bachelors, or PhD, or different other education. So US give about 300,000, sorry. About 25,000 students are from India every year. So this is the situation that, now my question comes, what is the average GPA, or what is the GPA of all the students coming in from India, or what is their? So because United States USCIS, which is a immigration authority in US, they only record your information. They only give you the visa, and they have the information related to that. So if I go to USCIS, I ask, can you give me the GMAT score of all the, or GRE score of all the students coming to USA from India? No, they can't say. They can say, okay, these are the number of students coming, and this is the situation, and this is their age. They can give age because, you know, they have date of birth of all the students. They have other thing, but they don't have their academic credential. Even they don't record what is their GPA, what is their TOEFL English language score, what is kind of university they are getting in. So let's say this is the real data. Let's say we collected these 500 students data, 500 students data, and based on that, I'm going to give the GRE score with, you know, within this range, 95% students will have the GRE score. So how I can get, you know, if I go to all 25,000 students, it's a very challenging for me to collect all 25,000 students, GRE score, TOEFL score, you know, all this, which is required for any student to come into USA. So basically, when international students file or apply for any higher studies, they need GRE score, they need English score, they need what kind of university rating. So this is a statement of purpose, letter of recommendation, CGPA, research, and chance of admission. So all this is required. So what I did, you know, I collected 500 students data, and this, based on this 500 students data, I'm going to make, you know, many predictions, many confidence, you know, what would be the GRE of at 95% confidence interval, what would be the average GRE of all the student, all 25,000 students coming from India. Actually, before going into this example, I must tell you this is the beginning of inferential statistics. You know what is inferential statistics? Okay.
You're making inferences, making
Yes.
guesses, but educated guesses of variables, right, to make your calculations.
So basically, this is a population, and this is sample. I mean, I give, before that, I give normal example, you know, about inferential statistics. Let's say we come across some health issues, and we visited to doctor, and doctor asks, okay, go and get it done, your these blood sampling and blood test. We go to laboratory, they take our blood. So we have almost, how much blood we have? 7 liter, you know, in roughly in a healthy body, 7 liter of blood is there. What happened? The doctor takes, or, you know, lab person takes 5 ml about, if I'm not wrong, 5 ml, 10 ml maximum. This is what they do, the analysis here, they diagnose, they, you know, do different. Based on that, they come to the, you know, they tell the report. This report goes to doctor, and what doctor prescribe the medicine for entire, you know, entire body. So basically, this is based on only 5 ml of our body blood. The doctor is able to, and after the analysis and all, they diagnose and they find the problem, and they prescribe for entire human body. Similarly, like I have 25,000 students coming from India to United States every year for pursuing. I don't have the information of all 20. Then I take the sample and I do the analysis of all the 500 or 200 or whatever number. And based on that, I come to the conclusion about entire population. I can infer about population. I can make some, you know, my decision, my judgment, my prediction, my understanding about entire population. So this is inferential statistics. Inferential statistics works when you take the sample, do your statistical test and analysis, and write about the entire thing, because it's practically impossible to collect all the you know, n numbers from the sample. is from the population, sorry, practically can't be possible. So this is what we are, starting from this chapter onwards. Hopefully it is making sense to all of you. So let me, okay, so this is what, so understand what I'm trying to say, what I'm trying to do about. So let's say GRE, what is the GRE based on this 500 sample? What is the GRE of all 25,000 students coming to USA? So I'm just going to go under statistics. Here I have basic statistics, one sample Z, and we have one sample T. So these are the two options, these are the options we are going to explore. One sample Z, one sample T, and one proportion, one variance. So these are the, because, these are the options. Now I'm going to do one sample T. Why I'm going to do, I will let you know. So I have a data which is in column C2. Perform hypothesis, I'm not going to do, and 95%. Okay, let's do it. Now I am able to make my some results, or I'm able to make my conclusion or something. So the mean of sample mean is 316 of all the 500 students which are in sample. Their GRE average is 300. A standard deviation is about 11. Now 95% confidence interval for mu. Mu, if you remember all the notations, mu is mean for population. This is mean for sample. So I am 95% confident that all 25,000 students coming from India, that their GRE would be in between 315.48 to 317.46, which is basically a 2 GRE point difference. So between 315 to 317, all students GRE will be there. What if I'm only 95% confident? What about 5%? There is a chance that it may not come. So 95% chance that it may not fall in this range. Then okay, so therefore I'm saying 95%, 5% ifs and buts or anything can be possible. Now what about if I increase this confidence interval? So here I'm saying 95%, let me do 90% and let me do 99%. So stat basic one sample, and let me go here and change to 99. I'm just doing it, and let me go with 90 also. Then you can compare, and then you can. So now I do it 90. So here we go. So this is a 90%, and here you see the range is smaller. That means you have a bigger risk. That means you increase the risk 10% chances. Therefore, you have the narrow range. But if you have bigger range, like you are 99% confidence, means you are increasing the range. Here you can see the range has been increased. That means what conclusion you can draw here? Higher the confidence interval, bigger is the range. Means, let's say I say my GPA at the end of MBA would be between 3.5. I'm 99% confident that my GPA at the end of MBA would be between 3.5 to 4. Means I have high range. High confidence means only 1% risk. So higher the range, that means higher the confidence, but low. But if I say my GPA would be 3.6 to 3.7, I'm 90% confident, or I am 80% confident that my GPA would be 3.8 to 3.9, means I have 20% still risk. Are you getting my point?
Yes, the larger the range, when you try to narrow in a more precise
Yes.
percentage.
Yes, that's correct. So now, I go, so basically now there are some, so basically you have the sample. You can do this in summarized way, means you can do the summary also. So basic statistics. Here you can, instead of you have, like mean sample size is 20, sample mean is this, standard deviation of the sample is this, and then you can choose different confidence interval. So basically you have to do, so basically confidence interval and significance level, they are up. So a 5% significance level, that means 95% confidence interval. Now I'm coming on some other principle, basic concept, why we call it this, why we call it confidence interval. So let me draw us look into this situation. Okay, let's say this is a normal distribution of, okay, this is a population, let's say this is mean, and these are the two. Now I take 10 times, let's say I take 10 samples. So let me put this right here. So one sample, and let's say one sample, its mean is here, and with, this margin of error, this is the 90% confidence, interval of, this is mean, and this is, so this is one sample, second I took, and second sample will have this range. So please bear with my diagram. I hope you will understand the meaning that I'm trying to explain here. Third time you do here, and it's a confidence interval is like that. So this is third. Let me do fourth. So I do the fourth here, and fourth. Similarly, I do fifth here. And let's say fifth is coming here. Remember this, because here, now sixth I'm doing here. So this is sixth. Seventh, so let's say seventh is coming very close to this. Eighth, let's say I'm doing here, this is coming here. Ninth, let's say here, and its range is here. And last one is 10th, which is here. Now you try to understand the meaning. I took 10 samples. So what happened? 9 samples, what they are doing? They are representing the true mean of the population, except 1%. So what would be my interpretation? I'm 90% confident that, or otherwise I'm 90% confident that samples will represent true population mean. Or let's say if this is a population, let's say 25,000 students coming from India, let's say I take 99 samples, or I take 100 samples. means sometimes I take 500, sometimes I take, and this is how I take 100 samples. Then 99 samples will represent the true population mean of GRE or GMAT or whatever of the people coming or students coming from India. Only 1% or one sample will not represent. Then what would be my statement? I am 95% confident that true GRE score will be between 315 to 317 or whatever. So are you able to understand what is the meaning of 90% or 95% or 80%? Is it making sense?
It does,
Okay, perfect.
at least for me.
Okay. So basically, this is the essence of this. If suppose there are like, you are doing Washington State public employee or, any survey that, or any information you want to extract from Washington State about income, about any number that, what you will do. You take, let's say, 100 samples, one from one state, one from one county, one from another county, let's say, and you have the true number of true population information that, okay, this is the real annual income of a Washington employee, state employee. I'm going to do in Spokane County, this county, King County, Walla Walla County, or this. You are doing 100 samples of income of the state employee. When you say 99 sample will represent the true population mean, if you look into that, only 1% will not represent, then you can say I'm 99% confident that true population mean between this range. So if this is the concept, if you understand this, let me go on other parts of this. Now you can ask very specific question. I can explain to you. So you can see my screen. Okay. Now let me open the okay. So this is, so like, this is the same example that I explained. Same example. So basically inferential statistics is about when you yes, very good question, Jennifer. So when population standard deviation is given, when the population standard deviation is given, then you use z-test. If population standard deviation is not given, then you use t-test. So you can see these are the, population mu, sigma, pi. These are denoted by sample x bar, small s, and p.
But what do you do if there's enough information to calculate the standard deviation? Like if it's not given, but you could calculate it.
Exactly.
Okay.
You can calculate, there are various methods so far we have studied for simple, simple reason. If you know that, the range 6 sigma equal to range. Basically, what is the range of 6 sigma? 6 sigma consists 99.73%, which is, we do approximately entire data range is within 6 sigma. So look into that. This is just very simple. 6 sigma equal to range. So this is range. Now, what is sigma? Sigma equal to range upon 6. So whatever lowest value, highest value minus lowest value divided by 6, you get the sigma. If you know the, the Poisson distribution, if average is given, square sigma equal to known as square root of sigma, square root of lambda. So if you remember all previous concepts, you will be able to calculate the sigma value. Anyway, so here, this sample mean, exactly, this is Mohammed, I'm coming over there. How we can, this is the most important question. What should be the appropriate sample size? What should be the sample size in order to do any research? What should be, let's say in Washington state, what is the census of Washington state? I don't know exactly. Let's say Spokane County has about 700,000 people. What should be the sufficient number of sample size that is sufficient for doing any research of Spokane County out of 700,000? So the sample size determination we have in this chapter. I'm coming over there, just 5-10 minutes. Look into how you can get the better consistency. So look into that. This formula, I'm coming over there. So actually, when you have the sample size big enough, every distribution follow the normal distribution. And that you learn in previous chapters. So look into this. So this is the expected range of sample mean. Please remember, if you remember this formula or equation, rest will be like same. So here what is the confidence interval? So this is mu. Look, this is for mu is a population mean plus minus z value that we can get from the table, or we know the z value. Sigma is for population. Square root means n, means small n means sample size. So if you know mu plus minus for 90% interval, 90%, the z value is 1.645 if you remember. For 95, 1.96. For 99, 2.576. Now, how you can get, precise interval? Look into this formula. You can't change the z value. If 90%, you are going to get only 6 point. What are the sigma and square or n? These are the two numbers, or these are the two values. They can change or they can have the precise. How you can get the precise or shorter interval? If n is high, means sample size is bigger. If you want to get precise range of sub-confidence interval, the n value means sample value must be higher, because this is in denominator. If higher is the denominator, this part would be lower, or the second option is sigma. Lower the sigma value, because sigma is directly multiplying with this number, then you can clearly understand sigma is so sigma and n, higher the n, smaller is the sigma, that we learn in the standard deviation. When I explained you, lower the close to 0, sigma is better. So same concept, you just please remember here. This is remains same. Let's say, whatever mean value we get, 315. And the this part is, let's say 2 plus minus 2. Then what is the range of this 313 to, if you subtract 2, which is 313, if you add 2, which is 317. So the range would be 313 to 317, for example. So remember, this is the formula that is going to be used in entire, but this is for only when sigma is population standard deviation is given. Then we use Z. Okay. Jennifer, it is making clear. So now I'm going to explain few more things.
Raj, can I ask you a quick question just to make sure I understood that? So the z-test is when you take the standard deviation of the whatever percentile you want, and you do that formula, and that gives you the plus or minus as an estimate. But if you have the standard deviation already, then you use the t.
No,
Correct.
if you have, no, basically read the question clearly.
Okay.
Read the question when it is, if information is giving the population standard deviation is given, then you use Z. So look into that. I'm going to show you.
Okay.
One sample Z test here. So here you can see known standard deviation of the population. Look into this. So if you are like, let's say you are taking here the ZRE, but if you know the entire 25,000 students standard deviation, then put here. So this is Z test when you know the population standard deviation. Look into this one sample T. Here you don't do because it considered the standard deviation of the sample. Look into this is T sample and no standard deviation.
Got it.
So asking for width, so what is the width? This is the range. So look into, some questions is asking only this part. I'm going to show you 1 minute. So basically this part is, Z sigma upon square root. This is called margin of error. What is called margin of error? And this is called standard error, means sigma upon square root is called standard error. So margin of error when you have the Z or T value, and the standard error when you don't have the Z and T value. So basically this part only called standard error. When you add Z before that or T before that, it is margin of error. So look into, for example, so standard error, when you have higher sample size, the standard error reduces because numerator and denominator, you can simply understand. So now I'm going for a so look into the mu, which is mu plus one time plus one time minus. So this is minus, this is plus, and this is confidence interval. So this is a confidence interval. So basically this is an acceptance region and this side is rejection region. So if I say 315 to 317 means lower limit is 315, upper limit is 317, and rest is rejection region. So this confidence interval, then this alpha is known as significance level. Alpha is known as if 90% is confidence interval, then 10% is significance level. So mu with known sigma, this is for Z test, confidence level for Z test. Now look into that 99, like I explained in the beginning, 95%, 90% confidence interval is smaller, 95% is bigger, 99 is biggest among three. Look into the range of each. I already explained this. Greater confidence interval means loss of precision, means you will have wider range. Most often, most of the software automatically takes 95% until you don't want to select your own customized confidence interval. By default, they take 5% significance or 95% confidence interval. So when we can assume normality, so very simple, n is greater than 30. sample size is greater than 30. Why we are doing? Because let me show you the Z and T table. So just a minute. Or it would have, I think. So let me show you the Z and T table. So let me T table or T distribution. So okay. Can you see my table? Degree of freedom means n minus 1. So if 1 means 2 sample sized, so this is T distribution. It is called student T distribution. It has T table. Look into the 30. Where is 30? So here you can look into 1.697. This is for 90 per. Yeah. So look into the n equal to 29 or 30. Here you look these numbers. Now I give you for infinity. Here doesn't have the infinity. So for 100, this is the value 1.66. Sample size 101 means degree freedom 100. And this is the difference you can see. So basically there is very a small difference. Let me open another one so that probably you can see this is the better one. And let me make it bigger. So here you can look, I think this is, So you can see this is a 30, degree of freedom 30, 1.699, and infinity, what is 1.645? Are you getting me? So any sample is more than, then we can consider it's normally distributed because the difference is very low. If you look into the 30, number 30, which is, or 29, 30 sample size greater than 30 means if you see 31, which is degree of freedom 30, look into this and look into the infinity. Sample size infinity. So look into the difference is very small. Therefore, so n equal to 30 is sufficient to use formula when we can assume. Now, student T distribution, this is another, instead of normal distribution, when the population is normal, but the standard deviation of population is unknown, then we can use student T distribution where where we use the standard deviation of the sample. So what is the difference here? No difference. Exactly the same formula. Instead of mu, here x bar. Instead of z, here t. Instead of sigma, here s. And sample size was there and sample size is here. Is it making sense? Okay. So confidence interval is 1 minus sigma. If 5% significance level is given, then automatically you can say 1 minus 5, which is 95% confidence interval. If 95% confidence is given, automatically you can understand significance level. So this is very simple. So degree of freedom is n minus 1, means sample size minus 1. So comparison of Z and T, so you can see here. For very small sample, there are some questions and in the fill in the blanks where you have to choose correctly, either it's a Z or T. For a small sample size, there's a difference significantly between T value and Z value, but for larger n equal to 31 and more, it is close to same. So you can see this is the statement. You can interrupt me. I'm coming on breath part. So ZMAT score, like, what is the 95% and confidence interval? So same thing. So you have to choose correctly which test you are going to choose. So now unknown sigma, this is and now confidence interval for proportion. What is proportion? Let's say I'm going to give some example. So let's say proportion is, this, for example, research. Here you have two options only. It's a research university or non-research. Eastern Washington is in Washington state, which are two university, which are state university, which are research university. Was University of Washington and WSU, they are research university. Eastern is not research university. So you can see this is clearly given. Now I do so. It has, this is a proportion. Now I go under statistics, basic statistics, and I go for one proportion. Now look into that. And I go under research. And by default, it is taking 95. So let it be. And now I go here. So what I can interpret from here? I can interpret there are 500 sample size. 280 are saying research university, which means proportion is 56% students are applying for research university, or they are into research university. What is the proportion? What is the proportion that all 25,000 students will get into research university? So that proportion is 51% to 60% student, all 25,000. 51 to 60% will be in research university. Is it making sense? So proportion means, or let's say, we graduate and not graduate students in Washington state, and we took a sample and we find 60%. 60% in our sample is graduate students in Washington state. Then I have to, infer about entire. Then I can run this and I can find between 55 to 65% all Washington residents are graduate. So what distribution to use for confidence interval? We are going to use only 4 distribution. We are going to use only 4. One is z-test, z, t, and proportion comes from z, and then we are going to use also chi-square distribution. Chi-square distribution is used for similarly we are doing for mean, for proportion. Then we also do for standard deviation or variance. So basically t distribution. I already said, in previous slide. So if you understand here, where is that? Here, you can see Hong. Yes, even this, because, a small sample, certainly how we can go to the normality. Certainly for 5 samples, 6 samples, we can't assume normality. Normality can be assumed when sample size is bigger. And this is the concept here. When we can assume the normality, sample is higher. Is it clear to you?
Yes, yeah. Hi. So basically, in the textbook, saying that we can use the central limit theorem when the n is greater than or equal 30, the sample size equal 30, at least equal 30. So I'm not sure if we can use that like the sample t and sample z for sampling that less than 30.
Yeah, so it is clearly here you can see if you have sample more than 30, you can assume the normality, but you know how, you have studied all previous distribution. When do we assume the binomial distribution is normal distribution? When n pi equal to greater than 10, and 1 minus pi equal to greater than 10, when you can assume lambda or Poisson distribution is normally distributed. So every distribution have its own, but here you can see the, n value must be greater, must be more than 30. Then we can assume this large enough. And large is, here the condition is more than 30. Is it clear?
Yes. So what if the sample size is less than 30?
Less than 30, then you see what, the question is asking. Let's say less than 30 and a standard deviation, then you use the t-test. So here you go. For example, let's say this is the and statistics, basic statistics, one sample t. So you have, because you know that value of z and t will be highly different. So, and even, in some cases it is given that more than 30 sample size, then you can use the sample size also. So look into this. I am just going to use sample size. Let's say I'm just going to do 31. If sample size is given, because mine sample mean is, let's say 45, a standard deviation is, let's say 5, and by default it is 95%. Let's do it. Just very simple question. So I'm going to use t distribution, and you see these numbers. Sample size is 31, which means normality, but even you will see the difference here. So okay and okay. So mean is 45, standard deviation is 5, standard. This is the 43 to 46. This is a confidence interval t. Now I go to z-test. Now look into the z-test.
Okay.
I have summarized data. Sample size 31. Sample mean 45. That, known standard deviation. Here, this equation is asking the population standard deviation, not sample.
Sample. C is for population.
It is asking the entire population standard.
Population.
If you know the population standard
Population.
deviation, I think some reflection is coming. Please mute your microphone. So, if I know the population standard deviation, then only I can proceed with this. Otherwise, I will go and use the t-test. Huang, is it making sense?
Yeah, so for the sample size that you put in 31 there, if I have sample size 15, I still can use the z-test and t-test. If I know, if the sigma known, I use the z-test, and if the sigma is not unknown, I use the t-test.
So if you have this number available, if you have this, use z-test. Means if you know the population standard deviation, you know the income standard deviation of all Washington state employee. Okay, go ahead and do this.
Okay, and then even if the sample size equal like 15, for example, I still can use this thing, right?
Yeah.
Okay. Just want to make sure, because in the text saying that I can use apply the normal distribution if the sample size at least 30.
Yes, at least 30, more than 30.
Okay, so if it's 15, can I use that or not?
So if you have a sample size 15, if you are having sample size 15.
Yeah, and it's not normal. Yep.
No, so actually, you have to understand which distribution you are working with. This confidence interval is only for z-test, t-test, and chi-square.
Yep.
Yeah, so
Yep. So my question right here is that if I have a sample size 15, so basically it's not qualified for 30 sample size. So can I use the t-test and z-test in this case?
so if you know if you know the population standard deviation, you can use the z-test. So this is
If I
the
don't know
must.
that, if I don't know if it's normal or not, too.
So if you don't know the standard deviation, then go for t-test.
Okay, I can do a t-test even my sample size is less than 30, right?
Yes, I mean
Okay.
that is no t-test is always, because there is a significance difference between z distribution and t distribution when sample size is lower, less
Okay.
than like 5 sample size, 10 sample size, the value of z and t will be significantly different.
Yeah, okay. But as long as I know I can use that, that's fine. Yeah, thank you.
So I mean, this is most important condition to know the standard deviation of population or not.
Yep. Okay. Okay, thank you.
You're welcome.
So Raj, so just in short, so if you have a sample size of it's under 30, but but it gives you the population standard deviation, then you could use the z.
Exactly.
If it doesn't give it, if it's not implicit in the word question, you have to use the t-test.
Exactly.
Yes. Okay.
So look into, I mean, I'm going to show you one more time here so that, you can make a clear. So this is the formula. Let me go here. So this is the formula or equation. And you can clearly see what we need for z. We need z value. We need sample size. Sample size is right here. You can see this is not population size. This is sample size. So in both cases, sample size is required. What is the difference between here and there? Instead of here, this z replaced by t and sigma replaced by standard deviation of the sample. Here, this is calling standard deviation of the population. So this is z test. Now look into the t. So here, for example, look into this equation. Here, x bar means sample mean, t means t distribution. Here, this is totally based on the sample numbers or sample. So this is sample standard deviation and the n is again the sample size. So in population, I mean z distribution, you also need the. So what is the common in both the distribution? This is common. Do you see? Sample size. Only the condition if you have 15 sample size and standard deviation is given, then use z-test. If you have sample size 15, a standard deviation of population not given, use this test. Huang, is it making sense?
Yes, makes sense. Yep, thank you. Then the reason I asked because in the textbook saying that like the central limit theorem apply for both z-test and t-test. So in order for us to use those equations, the sample size has to be at least 30. So
yeah, for normality, because how you can approximate when z-test is almost. So what happens, let's say sample size is 500. Or some people say, why that their statement significance. Let's say the sample size is saying 100. Then, the t value for 95%, people don't look into the t table and all. They just blindly put 1.96, which is also z value. Because, t value is close to approximately to z value if n is greater than 30. So by, whatever is the value of this t value, if you look into the table, it would be, it will not be exactly 1.6. It will be close to 1.6 if you look into table value, close to 1.6. But calculation and people directly blindly can do this. Instead of t value putting the from table value, let me go and see that what is the table value, and this is the z value. So just a minute. Just a minute. So here, okay, let me remove this. So look into this. This is the table value. And let's say for 120, what is the t value here? Here, this is coming 1.98. Are you able to see? This is 1
Yep,
point,
yep.
1 point. So this is 121. Sample size is 121. And this is 120 degree of freedom. But what is happening? Here, if, without looking, they can consider 1.96. 1.96. So this is slight difference, but with calculation, they understand it is normally, and we can switch t to z, z to t. I mean, means t distribution can be considered as z if n value is greater than 30. This is the interpretation.
Gotcha. Thank you.
You're welcome. Okay. So what I was explaining, I just, lost that track where I was. What I wanted to, just a minute. So let me recall.
Were you going to talk about chi-square?
Proportion. Yeah, I was talking about the proportion. So the proportion, like, I already gave, when you can understand proportion, when you can assume normality, n pi equal to n pi greater than 10, and 1 minus pi is greater than 10, you can consider this kind of distribution where you have binomial option in proportion to normally distributed, and you can use the formula. Here is the formula. This is the formula. P plus minus proportion, whatever proportion, like in our case 56%, 0.56 plus minus z value that you can get like 95%, so 1.96 square root. P means 0.56, 1 minus 0.56 divided by n. So number of sample in this case is 500, which that we are doing for Indian students. And then you can get the proportion confidence. So, I mean, the questions you can directly do. Now, there was a question about width. What is the width? So, like here 0.32, whatever is this plus is this, this is the margin of error. Plus minus 0.106 is margin of error. Now we have one more concept, finite population correction factor. It is called finite population correction factor. If I am correct, finite population correction factor. What is that? Basically, if you have population size known, sample is known, then you include this part in all the equations. So, this is before this we were doing this, but if you know this, you include this, you include this in the equation. What is this? This is called N, means, let's say in Washington, what is the census of, or let's say Eastern has 13,000 students roughly. We are taking a sample of 500 divided by 13,000 minus 1. What we get? So basically, this is very close, less than 1. This part is less than 1 always, because you can see here denominator is bigger than this. So it is very close to 1, but less than 1. When you multiply less than 1, you can see this value is reducing. So this is applicable when you have finite population. And so hope you understand this part. Let me clear this right. Okay. Now, very interesting question that Mohammed, you asked me about the sample size. Yeah. So now here we have the sample size. How we can decide what should be the sample size? So basically what we do here, we take this part. So this is called margin of error. This is called margin of error, and they call it error. Error equal to Z sigma square root. So E square equal to Z is. So basically they have just, solved this equation. They got N equal to Z square sigma square. Then they, do it. N equal to Z sigma upon E error and then square. Now you can calculate what should be N means sample size. What should be the sample size you need to get for any research or any conclusion. So Z, if you are going to do at 95%, so you know the Z value is 1.96. Sigma, there are various ways to calculate sigma, like I gave. Like you are doing a research on age of the Washington state, particular population of Washington state, you can see the range minimum maximum -1 divided by 6, and you can get the sigma value. Now error value, basically, sometimes it is given with 5% error, 10% error. It is usually in some cases given, but otherwise you can also get it. There are methods to do that, how to estimate sigma. So there are a couple of ways. First thing, to take a small primary sample, or we call it pilot sample. When you do a pilot sample, let's say before going for entire Washington, just do a 200 people data, pilot data. Based on that, what is S samples standard deviation that you consume or you use as a population or in your formula, so that you can replace. So based on different assumption. Method 2, sigma is equal to highest. So this is another one. Upper limit, lower limit. And so basically you use B minus A when you use uniform distribution. If you think everything is uniformly, then use the formula that is given in the uniform distribution. Let's say if you are using, okay, like I gave the example of low, 6 sigma. Upper limit means range divided by 6, because this is 6 sigma 99.73. You can use this method. Poisson, you can use the average, square root of average, to calculate the sigma. And similarly, you can also calculate the error term, but usually error part is given. So to eliminate population proportion, error can be so in this formula, normally if you look into the questions of the book, you will see they give you with error 5% error or 10% error or 20% of error. So normally they give the 5% error, 0.5 at 95% confidence, so 1.96 sigma. You can calculate using different these methods, and then you come to know what should be the approximate sample size. Similarly, if you are doing something for proportion, this is also the formula, the N equal to Z upon E pi 1 minus pi. So pi value is very important to consider, because when you do anything, like if you flip the coin 100 times or 200 times, you will get 50% head and 50% tail. So whenever you do proportion thing, you assume pi is 50-50. So assumption for pi related n calculation, it depends on 50-50 if not given. So between 0 and 1, E is also between 0 1. So and assume pi equal to 50. And if you don't want to assume this is rough, first assumption, then you take the pilot sample. Based on that, you decide, or based on historical data and other ways you can do that. So now after that, one more important concept is chi-square test. Chi-square, when we are talking about mean, so we have the z-test, t-test. When we were talking proportion, we have a proportion test. Now, if we compare the standard deviation or variance, then in that case, we have the chi-square test for doing the confidence of. So chi-square, upper limit, lower limit, this is the formula. If you are comparing whether what should be the, so let's say, this is, okay, this is my same example. So ZRE and what is the standard deviation is, what should be the within what standard deviation all the ZRE score, all the 25,000 students ZRE. So what I do, I go under this, I go under statistics and basic, and here we have the variance. And okay, so I go under one each in column. So perform, I am not putting here by default 95%, and now you look. So standard deviation is 11. So basically I'm doing a variance. So 11.3 multiplied by, so that is variance. The 95% for sigma using this method is between all the 25,000 student standard deviation, GRE standard deviation will be 10.8 to 11.9 for chi-square. So 95% CI for sigma using chi-square would be between 10.6 to 12. So different methods are there, and so basically you can see the confidence interval for variance or standard deviation. Is it making sense?
So for example, so when they're asking for a variance, you go to stat and use it. What is this variance to? But is that when you have two variables?
No, variance actually, every data has the standard deviation. So what is the variance, the relationship between standard deviation and variance? So
Right.
So this is standard. So basically,
Square root.
yeah.
Oh,
So
sorry.
variance equal to variance is equal to this standard deviation.
Right.
This.
And then squared variance equals to, okay.
So okay, this is a standard deviation. Variance, basically 11.333 into 11.3. So basically, now this is the standard deviation of 500 students or 500 GRE. Now I have to see what would be the overall, how confident I am that, that standard deviation will be in particular range, or with 95% confidence, what would be the range of standard deviation of all 25,000 students. So this is, based on this method, this is based on this. Because, the standard deviation will also vary when, you will have all 25,000 students. In 5% cases, it may not be there. Am I able to answer your question?
Well, yeah, that makes sense. But I mean, when I was talking in Minitab, how do you, if you go back to stat and
Yeah, okay. Oh, sorry.
yeah,
Okay, just a minute.
sure.
Here, stat, under stat, basic statistics. Here you have one variance,
Yeah.
and here you do. You can do also summarize sample variance, sample standard deviation. But since we have here, so this is also option. Here we have other options also. So let's say basic statistics. And so what we are going to do this time, only going to touch one variance, one proportion, one Z and one T.
Okay. So we're not going the two variants.
We are not going to do, because we are just dealing with one sample.
Right. Got it. Okay.
Now we have some sample size determination, how you can calculate sample size. So I have given some questions, sample size. Actually, I don't know about the Minitab, and there's a significance difference when you do the calculation using Minitab, when you do by hand calculation, like just putting the numbers in this formula, like just a minute, for example, let's say this is the formula. And if these numbers are given, you get like 620 n equal to, but when you do through Minitab, you get different number. So this is only one thing which I could not understand in last 3-4 years, why it is showing different between Minitab and hand calculation. However, I have included the difference as a margin of error in answer in fill in the blank. So you will not, either method you will do, you will be perfectly all right. But in practical, when you use Minitab, when you use hand calculation, there will be difference. So don't get upset or anything. But if you do either method, you will be fine in fill in the blanks. And
Okay.
so here I go and I show you statistics. Here we have just a minute. Where is one sample Z1 variant? I'm just because I forgot, where is the option of sample size? Here you can see power and sample size determination. So here use the sample size estimation, and now you can see. Now it is very simple. You have to choose the right option, which sample size. So mean and estimate sample size. So standard deviation, let's say 2 or whatever standard deviation that you can calculate or you get in question. Estimate margin of error for confidence interval, or what you need to do, estimate margin of error, or we are going to, let's say 20%. So I just put 2.2 and I get the sample size. So the sample size would be 387. And margin of error is E. In formula, this is the margin of error that we do. So please look into this. E is margin of error. And we are going to do for mean. Now, similarly, you go for different sample size estimation. Now you have a standard deviation normal, and now you have variance proportion, like binomial situation, which is proportion that we just spoke about research. In that case, proportion is like 0.56. Estimate sample size, margin of error like 0.30% or 30. Then you see the sample size 13 is sufficient. So this is
Interesting.
This is the first option under power as sample size.
So this is the only way to find the margin of error in Minitab.
Yeah.
Okay.
So you can do, basically this part, this option in Minitab, can help you to do this part. This and proportion part when you see the binomial option. So if you have any of the information, you can calculate other option. However, please, again, the difference between if you put the numbers here in this this formula and put here, you will see significant difference.
So, like I said, but you put an error, standard error in the answers. Though.
Yeah, in answer, let's say, by Minitab is little smaller than the one. Let's say Minitab is giving you 621 and hand calculation is giving you 673. So the difference is 52. So I put the range 620, let's say I put the answer 620, 650 or 645 is 645. And I put the plus minus, that can cover this answer, that can cover this answer. So you will be all right. Any other question?
Well, I have a question from last week's fill in the blank.
Yeah, I will. Yeah.
Oh, yeah, but I wanted to wait till everyone's done with today's current material.
Yeah, so the birth, you ask birth, what is the birth? So let me show you the birth also. Anyway, so this is the birth. So 95%, this is the birth. Any other questions? So what is the birth? This is the confidence interval birth. So this is the width in case of this is the lower to upper. Some question is asking only plus minus value, means some question is only asking margin of error. Please remember in some question, it is only asking margin of error means after, after plus minus value. So you have to subtract by hand, but you will get the number and you would need to see what is demand of the question.
Oh, I see.
Okay. I mean, because, questions are framed little bit, so that you can critically think and answer. It is not like a straightforward. The answer Minitab comes at the last stage. First, you need to figure out what is the problem. What is the information given and what is the demand of the question. Then you can plug the number in Minitab to do that. If you don't have that, that thinking is wrong, then everything will be screwed up. Okay, so let me stop this recording and whatever is your question, I can answer. So just a minute.